Hello, welcome back to my YouTube channel. My name is Venon Insofa, and in today's video, we're going to talk about jugular venous pulse. But if you're new to my YouTube channel, please go down and hit the subscription button. And also don't forget to like and share this video. I would really appreciate that. So without wasting time, let us get started. First of all, we need to start with the definition of jugular venous pulse. Jugular venous pulse, this can be simply defined as the pulsation that you are going to see in the right internal jugular vein. So you can see here we have got the right internal jugular vein. This is the one that we use to measure jugular venous pulse, not the left internal jugular vein. But what's the reason behind that? The reason behind that is that the right internal jugular vein and the right atrium, they are connected without any intervening valve. So there are no intervening valves between the right internal jugular vein and the right atrium. So the pressure in the right atrium, when it builds up, is going to extend this right internal jugular vein because there are no valves. Okay, so when we talk about jugular venous pulse, this actually corresponds to the changes of the pressure inside the right atrium. So when the pressure builds up in the right atrium during contraction or atrial systole, what will happen is that pressure is going to be propagated through this vein, and it's going to be seen as a pulse or as a pulsation. And when the pressure reduces in the right atrium, that's during atrial diastole, what's going to happen is that another wave is going to be sent through this same vein. So when talking about jugular venous pulse, simply talking about the pressure change in the atria. And this pressure change is going to be seen as a pulsation in the internal jugular vein. The internal jugular vein is located behind this muscle that we are calling sternocleidomastoid muscle. And it's passing between these two heads of this same muscle. So you can see this is the head of this muscle and the other head. This vein that you can see there, this is our right internal jugular vein. It's a tributary of this vein here that we are calling brachiocephalic vein. So we have got the right internal jugular vein there, brachiocephalic vein. And then we have another tributary right here. This one is called the right external jugular vein. So the right external jugular vein is more superficial to the right internal jugular vein, because the right external jugular vein is going to pass on top of this muscle, the sternocleidomastoid muscle. It seems to see this right external jugular vein than the right internal jugular vein. And then here what we have, this is our subclavian vein. Okay, so subclavian vein, right external jugular vein, right internal jugular vein, they are going to meet to form the right brachiocephalic vein. That's very important. Now, what are the features of the jugular venous pulse? So, how can you differentiate it from the carotid pulse? Because the carotid pulse, this is a pulsation that is within that common carotid artery. And the common carotid artery and the internal jugular vein, they are lying close to each other. So it's very easy to confuse jugular venous pulse with common carotid pulse. That's why you need to know the differences. What are those differences? You can remember this mnemonic, police. So P is for palpation. So when you look at the jugular venous pulse, this one you can't palpate it. So when you try to palpate it, it's going to disappear. And then occlusion. O is for occlusion. What does it mean? Readily occludable. So this one can be easily compressed or easily obstructed. So if there's anything blocking the vein, it's going to disappear. And then the location. So the location, it's passing between the two heads of sternocleidomastoid muscle, and it's lateral to the carotid artery. So it's going to be lateral to the common carotid artery, as you can see. And then what will happen? During inspiration, the jugular venous pulse is going to drop. So it drops with inspiration. When you breathe in, you take a air in, it's going to drop. Then what about the contour? It has a biphasic waveform. So you're going to see those positive and negative waves. I'm going to talk about it. What else? You're going to find that jugular venous pulse, it drops when sitting erect. So when someone is sitting erect, it's going to drop. That's why patients must lie down at 45 degrees. How are we going to measure the jugular venous pulse? So a patient must lie down at 45 degrees angle. And then what you are going to do is that you are going to locate the jugular venous pulse in the neck. And then when you locate it, so as you can see here, I've got our sternocleidomastoid muscle with two heads. This is our external jugular vein, our internal jugular vein is there. We are using the internal jugular vein to measure our jugular venous pulse. So we are going to locate the jugular venous pulse in the neck. So when you locate the pulse, you are going to get a cardboard and a ruler. You're going to press the ruler at the angle of Louis, and then you're going to get the cardboard, you're going to put it at the location of the pulse and perpendicular to the ruler. And remember, the patient is lying at the surface at 45 degrees angle. So you're going to locate this, or you put it at the location of the pulse and then perpendicular to the ruler. Then you're going to measure the centimeters. So you're going to measure the centimeters from down there up to the point where this cardboard is meeting the ruler. So let's say that you find your value as 4 centimeter. So you're going to say 4 centimeter plus 5 centimeter. The 5 centimeter, this is simply the approximate distance from the right atrium to the angle of Louis, or to the sternum. So a distance from the right atrium to the sternum is approximately 5 centimeter. So 5 centimeter plus the value that you found here, which is the 4 centimeter, you are going to get 9 centimeter. But this is 9 centimeter of water and not mercury. So here the units is centimeters of water. Okay. The 5 centimeters we're adding to the value that we found here. It is simply the distance from the right atrium to the sternum, because the right atrium is located at the angle of Louis. So always the value that you find, you're going to add 5 to that value. So the normal value that you have to measure, the normal should be between 6 centimeters to 8 centimeters of water. When it's elevated above 8 centimeters of water, it means there's a problem.